Okay, we're going to start with some examples here using hyperbolas. Not too bad. You'll see we'll start off similar to how we did the ellipses. If you look, we're asked to sketch a graph of this hyperbola. It's not in its standard form. Standard form, this number would be equal to 1. So to deal with that, which we probably did with hyperbola, ellipses, is divide both sides by 36. Okay, that'll get us our 1 over on the other side. We'll get x squared over 9 minus y squared over 36 equals 1. Okay, now let's notice a couple things here. First off, x squared's coming first, so it's going to open horizontally. Okay, we can probably plot some things pretty quickly here. Our center, notice here h and k, in this case equals 0, 0. So our center is at 0, 0. The distance from the center to the endpoints of my horizontal axis is 3. So there it is. And because x comes first, I know it's opening left and right. So I can confidently label those as my vertices. The endpoints of my vertical axis are 6 units away. 1, 2, 3, 4, 5, 6. Okay, now here, if this was an ellipse, we would just draw in the ellipse. See, that's how it's very similar to dealing with the ellipse. But it's not. Okay, it's a hyperbola. So what we have to do is the different technique. We need to construct our box using the endpoints of our transverse and conjugate axis. Once we do that, we can draw in our slant asymptotes. There they are. Okay, and since it's opening side to side, or left and right, it's horizontal, I know that I can just draw it in like this. And see, our slant asymptotes give us the guidelines to how wide to draw that. Okay? One other thing, although I didn't ask you to do this, we're going to go ahead and do it right now. We're just going to find where the foci are. Now remember, foci, the distance from the center to the foci is can be found in this way. So I'm going to go ahead and do, in this case I know A and B, so I can say c squared equals 9 plus 36, or c squared equals 45. So c equals the square root of 45. Okay, 3 squared is 5. A little bit less than 7. How do I know that? The square root of 49 is 7, so square root of 45 has to be a little bit less than that. 3, 4, 5, 6, 7. A little bit less than that is our focus. And again, notice it's on our transverse axis. It's running horizontally. It's inside the hyperbola. Okay, let's take a look at the next one here. Write the equation for the hyperbola in standard form, graph the hyperbola. Include the foci and the asymptotes. Okay, well, a little different here because this is not in standard form. But that's okay. In this case, it looks like y is going to come first. That's not always the case, but we'll just assume that it is here. Okay, and what we're going to do is we're going to group our y terms together, group our x terms together, and I'm going to take the constant to the other side. Alright, now we need to factor what we're going to have to do, okay, if we're trying to get to something that looks like this. Oops. Okay, we're going to have to complete the square. Actually, we're going to have to complete the square twice. So what I'm going to do is I'm going to group here. And actually, I never group with a negative, so I'm going to put a plus, negative there, and group. So now this becomes plus negative 4x squared. And then I'm going to factor some stuff out. I'm going to factor a 9 out, I get y squared minus 2y. Okay, and I'm going to take a negative 4 out, and I get x squared minus 6x equals 63. Alright, from there, I'm going to complete the square inside the set of parentheses. And you can think of this a number of ways. Alright, I'm going to take a 9, and if I complete the square inside, I'm going to add 1, okay, minus 4 times x squared minus 6x, and then I'm going to have to add 9 here. Now, what you have to think of is, what did I actually add? When I added this 1 inside here, what did I actually add to that side of the equation? Well, I actually added 9 times 1. So, I have to add 9 to the other side. 9 times 1. Okay? And I have to also add negative 4 times 9. So in this case, I'm going to have to add negative 4 times 9. Okay? Once I do that, I end up with 9 times y minus 1 squared. I completed the square. That's the whole purpose of doing this. X minus 3 quantity squared equals, okay, I have 63 plus 9, 72 minus 36 becomes 36, and then to get it in standard form I have to divide both sides by 36. Okay, we end up with y minus 1 squared over 4 minus x minus 3 over 9, x minus 3 squared over 9 equals 1. This is our equation in standard form. Okay? That's the one that we're going to graph. Now you got to be careful. A lot of things that can throw you off here. But here we go. Our h value is 3, and our y value, our k value is 1. So the center here of this one is at 3, 1. That's our center. The distance to the endpoints of my vertical axis are 2 units away. Notice y comes first, so these are my vertices. Then the endpoints of my horizontal axis are 3 units away. Okay. We use those values to draw in our box here. We draw in our box to draw in our asymptotes. Okay, and from there we can draw in our hyperbola. In this case it's opening up because y came first. Okay, if we needed to include our foci, which I asked you to do, our foci, remember, c squared equals a squared plus b squared. So in this case, we can say c squared equals 4 plus 9, which c squared then equals 13, or c equals the square root of 13, somewhere between 3 and 4. So somewhere in here is our focus. And there's our focus. Okay. Somebody asked you for the coordinates of our foci. In this case, you would just take your center. Remember, our center was at 3, 1, and you could say it's at 3, comma 1 plus or minus the square root of 13. That's where our coordinates of our foci lie. Okay, find the equations for the asymptotes in example 2. Alright, good problem here. Look, first off, we should be able to just look at this and we can tell. Our slope, right? Our slopes, we know, should be plus or minus b over a, or 9 over 4. oops, I'm sorry, 2 over 3, 2 over 3, that was b squared over a squared. But if you look, you can see it. The slope of our asymptote here is up 2 over 3. So it should be 2 over 3 and negative 2 over 3. Okay, now we can actually see our y-intercepts here also should be negative 1 and positive 3. But let's verify that, okay? So quickly here are the equations of our asymptotes. Let's say here's asymptote 1 and asymptote 2. Oops. Alright. Asymptote 1 we can say is y equals 2/3 x plus some y-intercept 1, and asymptote 2 is negative 2/3 x plus some y-intercept 2. Well, in order to solve for these y-intercepts, we need to have a point that's on the line. Well, what's convenient is the center, in this case, which is HK, is sitting at 3, 1. And that point is on both of these. So I can take that point, okay, and I can plug it in here. 1 and 3 equals 2/3. We'll multiply that here, and we get 2 plus b1 equals 1, or b1 equals negative 1. So that means our asymptote 1 is y equals 2/3 x minus 1. There's one of our asymptotes. Our other one, if we plug our point in again, okay, negative 2/3 plus b2, we end up with negative 2 plus b2 equals 1, or b2 equals 3. So our second asymptote is y equals negative 2/3 x plus 3. Alright, that's it for those examples.